Okay, so this video is to make a correction for example 3 on section 4.8. When I solved for the shadow, I just solved for the hypotenuse, which is actually not where the shadow is. This is just the length of the sun ray. All right, so we had a building that was 600 feet tall. There was a 20-degree angle of elevation, and we were supposed to solve for the length of the shadow. So I incorrectly solved for the hypotenuse. We're supposed to solve for the length of the shadow, which according to the theta here is actually the adjacent side. So because I'm looking for this side down here, and I know the opposite side, I'm going to use tangent because tangent uses opposite and adjacent. Okay, so I know that tangent of theta, which is 20 degrees, equals the opposite side over the adjacent side. I'm just going to put S for shadow. And in order to find S, I'm going to just cross multiply. So I get S times tan 20 equals 600. And then I'll divide both sides by tan 20 so that I can get S by itself. Okay, so I just kind of multiply both sides by S. And now I'm dividing both sides by tan of 20 degrees. Okay, so now I'll have S by itself. And then I'll plug it into the calculator, 600 divided by 20 degrees to figure out what the length of the shadow is. And so if you're using Desmos, just make sure your calculator or your graphing calculator, make sure it's in the right unit. So I'll change it to degrees. And then I have 600 divided by tan of 20 degrees. And so S is about 1,648.49 feet. So that's the length of the shadow. Okay. Sorry about that.